In this video, I introduce Dream to Control learning behavior by latent imagination. Training in reinforcement learning agents in real environment requires a large amount of real-world interactions because most of the features in training images don't relate to the tasks. Dreamer is a reinforcement learning agent that learns along horizon behaviors from images purely by latent imagination. An actor-critic algorithm is trained to learn reward and policy models in world model environment, as shown in here. This is the dataset of experience. The learned action model in the real world generates a new experience for growing the dataset. This learned latent dynamics. The world model predicts future rewards from actions and past observations so that the reinforcement learning agent is trained in the latent space. This value and action learned by latent imagination. This value model, this action model, this stays in the latent trajectory. The action and value models are learned from the predicted latent trajectories in the latent space. The visual control is formulated as a partially observable Markov decision process with a discrete time step t, continuous vector valued actions at generated by the agent and high dimensional observations and scalar rewards OT and RT generated by the unknown environment. The goal is to develop an agent that maximizes the expected sum of the rewards. The latent dynamics model consists of three components, namely representation model encodes the observations and actions to create continuous vector-valued model states ST with Markovian transitions P. The transition model predicts future model states without seeing the corresponding observations that will later cause them, namely this Q. The reward model predicts the rewards given the model state. P generates samples in the real environment, and Q is their approximations that enable a latent imagination, as shown here. These are three models and shown in this figure. From the dataset of past experience, the agent learns to encode observations and actions into compact latent states. For example, via reconstruction, as shown here, as encoder, this decoder, and predicts the environment rewards. Imagine the trajectories start at the true model states ST of observation sequences drawn from agent's past appearance. The model predicts the next state in the latent space, ST, reward RT, or policy AT. The objective is to maximize the expected image reward with respect to the policy, as shown here. Consider image the trajectories with a finite horizon h. A dreamer uses the actor-critic model to learn behavior. The action network predicts the actions in the latent environment, and the value network estimates the expected image reward that the action model achieves from each state ST, as shown here. This is the value model, and this is a reward model, as shown here. The action model maximizes the estimate of the value over actions, while the value model matches the estimate of the value that changes as the action model changes. To update the action and value models, the value estimates V lambda are computed for all states along the imagined trajectories. The objective for the action model Q5 is to predict the actions that result in state trajectory with a high value estimates, as shown here and in this figure. The objective for value model V psi is to regress the value estimates as here and in this figure, where Q theta is a reward model. The value model is updated to regress the targets around which the gradient stops. The action model uses analytic gradients through the learned dynamics to maximize the reward and value predictions, which depend on the imagined states. And then the learned model predicts and executes the actions in the environment to grow replay buffer, as I show you here. For more details, please check with these references. Thank you. Bye.